Hello, I'm Shadi, and my team consists of Ilya and Yasim, and we are Team 10. Our research looks into introducing automated planners into the red teaming process. Now let's quickly go over what red teaming is. Red teaming is a practice in which a team emulates as an adversary to simulate an attack on an organization to determine its readiness to respond to a cyber attack. This process follows the general flow of reconnaissance, infrastructure development, and initial compromise. It ends when the specified adversary goals are met. As opposed to a defensive method of analyzing a system, red teaming offers concrete measures of a system's security by demonstrating actual attack paths that an adversary may take to penetrate the system's security. Many tools exist to automate the redundant aspects of this process, but something is missing to enhance the automation of this process. So what is missing? Planners. Now you may be asking, what are planners? Well, planners are tools that automate the planning phase of events, and in our case, it is red teaming. There are three main types of planners that are more catered towards our cause: state space planners, planning graph planners, and hierarchical task network-based planners. State space planners are classical algorithms for path finding that introduce a more informed exploration through added heuristics. Planning graph planners enhance the attack plan drafting step by generating planning graphs from the problem, highlighting the data structures that locates the best path to a goal-satisfying layer through compactly presented possible outcomes of the specified problem. Finally, hierarchical task network-based planners present the user with the best strategies through constraining the search to only viable paths for the problem at hand. Through forming a decision tree method in our planner, it could take in information as input and give you multiple routes to your end goal and provide you with the outcomes that you can expect at each step. The decision tree learning method is a technique by which a decision tree or a prediction model is utilized to make conclusions about a target through relating observation to the predictive model. This method is highly used in statistics, data mining, and in our case, machine learning. I'm going to move it on to Ilya, who's going to talk about the previous frameworks and
So now I'm going to be talking about previous frameworks that were implemented for red team automation, as well as the issues that came along with them. So many organizations, including the United States Department of Defense, have acknowledged that there's a general lack of red teaming experts within their organization who can perform cybersecurity tests on their own systems. And therefore, there have been many attempts to remedy this by introducing either red team automation or introducing new solutions to existing red team automation tools. One such proposed solution was to the Cyber Automated Red Team Tool, or SART for short, in the Department of Defense. What they tried to do was streamline red team automation by incorporating open source tools such as Nmap and OpenVES, as well as automated Python scripts to SART in order to supplement the need for experienced red team operators. The goal was essentially to develop a system to conduct red team assessments during development, operational testing, and normal field operations of Department of Defense systems. However, there were several issues that came along with this, such as the fact that it could not attack multiple targets on a network, which means it would be impractical for a large-scale organization. Another issue that came along with this was the fact that it did not clarify specific tools used prior to this solution, which means that the need for red teaming experts would still be required, which would be counterintuitive to red team automation. Now, another attempt was the development of something called the Cyber Attack and Defense Emulation Agents, which, unlike the previous attempt, tried to integrate both red team and blue team tools as separate agents in a network security assessment. Now, this framework had extensive use of reconnaissance tools against a target network, which it used to collect information such as ports, IPv4 addresses, and misconfigured files to make a decision on a possible attack technique, as well as predict the actual outcome of that technique. Now, the issues that came along with this was the fact that it still used high-level emulation tools, which required cybersecurity specialists to configure and implement. It also had limited attack techniques compared to many other open source frameworks available on the market. Finally, this framework was only available for Linux OS, which means it was not compatible with other OSs that are streamlined for organizations such as Windows or Mac OS. So with those examples in mind, here are some key aspects in the development of these researched frameworks that were missing, which would be crucial for any kind of red team automation. So there needs to be a development of a decision tree learning method software. What this is, it's a technique that gathers information of a target network and then utilizes predictive analysis to formulate the best decision for an attack to carry out. What this will essentially do is eliminate any human error when deciding what kind of attack to do, and then any other redundant tasks that come along with this process. This kind of software can also be retrofitted to adapt to different vulnerabilities on a network. Now, unlike this decision tree software, which will tell you what kind of attack to perform, the hierarchical task network-based planners are used to display the most efficient route of attack based on the specific goal that you have set in mind. This will aid red team agents in graphing data structures to locate the best path of attack, while the decision tree will give you the best type of attack to carry out based on the path. So now I'm going to pass it on to my partner Yasim, who will talk about the next section, which is existing methodologies.
Alright, so I'll be talking about the existing methodologies in red team automation and planning graphs. So PGPs, or plan graph planners, are automated planners that use planning graphs from the system to gather information and create attack plans. So these attack plans are created in order to find the best path to launch the attack. So looking at the example here, we talk about LinGraph. LinGraph is an existing plan graph researched by Sitar Kortik and Uluk Soranli. So it uses a framework based on precondition and provides a layer of abstraction of system behavior. And it would be a useful method incorporated in existing and upcoming red team tools. The Lin graph is based on previous renditions of linear logic and planning problems, which were weaker. Lin graph introduces intuitionistic linear logic to planning problems and creates a planning graph for each problem. Hence, each problem could be like each step. The tool has been created to function in a large-scale environment. For instance, when a large company is in red teaming activities, and this algorithm can be used to plan detailed attack vectors to reach a common attack goal. The tool is capable of finding multiple objects that are functionally identical. However, it is complex from different sources as it did not define the concept of state node equivalence. Incorporating this method to newer tools will create more detailed plans when required by the company. So, looking at the current tools in red teaming automation do not incorporate decision making and planning tools such as PGPs, as we mentioned earlier. Hopefully in the future, we create new red teaming toolkit which will feature automated attack planners and decision tree models, which would help it make it easier for companies to be able to have a larger roadmap and be able to plan their attack vectors more meticulously. And then the roadmap would feature possible attack vectors, which will help adversaries constructing a plan of attack on various system targets. Thank you for watching.